This lesson is also on linear regression, which we learned how to do yesterday, but we're going to be adding a couple extra steps to the problems. So this first part should just be review. A scatter plot is a graph that relates two groups of data using ordered pairs, otherwise known as points. Linear regression is a trend line that shows the relationship between two sets of data that can be used to make predictions shown in a scatter plot. You may also be asked to find the line of best fit or data that has a linear relationship. All right, so we did this yesterday. You put the data in the calculator in list 1, which the calculator calls L1, and list 2, which the calculator calls L2, and you create a scatter plot. The equation for linear regression using the calculator is y equals ax plus b, where you fill in the a and b part with numbers that the calculator produces. All right, if you need to, pause this video so that you have more time to fill in your blanks. All right, another thing we talked about yesterday was the correlation coefficient, which is your R value. So the closer R is to -1 or +1, then the stronger the correlation. So for this first one, your line is going up, so that is a positive correlation. And as you can see, the dots are pretty close to the line, so R will be close to +1. R will be close to +1. This next example, your line is going down, so that is a negative correlation. Once again, the dots are pretty close to the line, so R will be close to -1, maybe -0.9 or -0.8. And the last one, the dots are scattered so that there is no correlation. So your R value would be 0. All right, so let's do an example. So for this first one, state the correlation coefficient. So the first thing you would need to do is put it in stat. So on your calculator, hit the stat button, go to edit. L1, you're going to put in 1, 2, 3, 4, 5, and 21, 15, 12, 9, and 7. All right, feel free to pause if you need more time. Then you hit stat, go over to calc, and we're doing linear regression, which is number 4. Enter, enter, enter. And as you can see, my calculator does not have the R value on it, so I have to turn that on. So you go to second 0, and you scroll down to diagnostic on. They're in alphabetical order. So go down to diagnostic on. Hit enter. All right, and now go back to stat, over to calc, down to number 4. All right, so your correlation coefficient is your R value. So let's go 3 decimal places today. So that's -0.978. And then state the line of best fit. That is your y equals equation. So the y equals is -3.4x plus 23. All right, is the model a good fit? The answer is yes, because it's close to -1. So if it's close to either +1 or -1, so I always think about it if it's more than 50 cents. So this one's about 98 cents. So if it's more than 50 cents, then the answer is yes. All right, this is what we're adding on today. Using the regression equation, find y when x is 18. So we need to plug that into our equation. So -3.4 times 18 plus 23. Just type that all in your calculator and you get -38.2. Okay. All right, for this next one, using the regression equation, find x when y equals 46.8. So this one we're plugging in for y. So let me write 46.8 equals -3.4x plus 23. So this one actually has to be solved. So draw your line, so you would subtract 23, which gives you 23.8. And then you would divide by -3.4 on both sides. And you get x to be -7. So that is your answer. Once again, pause this video if you need more time to write. All right, example number 2, circle the correlation coefficient that represents the given data. So once again, I need to put it in stat, edit. To clear out, you go up to the top and you press clear, enter. Clear, enter. Just gotta go up to L1, clear, enter. Do not press delete. All right, so I type in 1993. Oh, made a mistake. 1993, 1994. 1995, 1996, 1997, 1998, 1999, and 2000. And then for L2, 340, 369, 402, 430, 457, 489, 527, and 574. All right, press stat. Go over to calc, down to number 4, because today we're doing linear regression. Enter, enter, enter. And your R value is 0.996. That's positive. So that would be answer choice C. All right, B says circle the equation that best represents the given data. Go back to my calculator. Let's first look at the B. That's going to be the easiest. B is -64105. It's negative, so that rules out C. And the calculator always gives you a decimal, and so it's giving you 32.3. And we have fractions. So we have to figure out which one of these fractions is 32.3. So on the main screen of the calculator, or just right here, I could type in 96 divided by 3. Do you get 32.3? Nope. If you type in 97 divided by 3, you get 32.3. So B is the best answer. All right, what amount of money will Recreation earn in the year 2011? Here you got to be careful. So year 2011, years are on the left, which means they are your X. So this is an X value, 2011. So I'm going to plug it back into my equation. So Y equals 97 over 3 times 2011 minus 64105. And this one's already ready to type in the calculator, and you get approximately 917, and that's actually billions of dollars is your answer. All right, pause the video if you need to, otherwise flip it over to the back. Number 3, you have Olympic 500-meter men's gold medal speed skating times. A, find the linear regression model that fits the data where X, L1 is the number of years since 1980. So they're putting an extra twist on this one. So you need to be really careful and pay attention to when they tell you something like this. They want L1 to be the number of years since 1980. So we need to go through and change these. So 1980, how many years since 1980 is 1980? 0. How many years is 1984 since 1980? 4. How many years is 1988? 8. 1992, 12. 1994, 14. 1998, 18. So in my calculator, if you don't do that step, you'll get the wrong answer. So in the calculator, I'm going to go to Stat, Edit, clear out what's in there. So I'm typing in 0, 4, 8, 12, 14, and 18, 422, 432, 404, 420, 395, and 382. Stat, calc, number 4, enter. All right, let's go 3 decimal places. So y equals negative 2.292x plus 430.56. Sorry, y equals negative 2.292x plus 430.56. You can write the 0, but you don't need to. All right, predict the amount of time in the year 2013. Well, years is the top column, so that makes it your x value. But just remember on this problem, they want x to be the number of years since 1980. So I need to do 2013 minus 1980, which is 33, and that's what I'm plugging in for x. So negative 2.292 times 33 plus 430.56. All right, let's type that in the calculator. Negative 2.292, parentheses 33, plus 430.56. And you get 354.924. 354. 354.924. All right, we're skipping number 4 on your notes and going to number 5. Number 5 says, what was the average temperature for New Bern, North Carolina, which has a latitude line of 35.1083 degrees north? All right, well, the only way to answer that question is to get your equation first. So I need to put them in stat. Clear that out. So 0, 10, 20, 30, 40, 50, 60, 70, 80. And in L2, 79.2, 80.1, 77.5, 68.7, 57.4, 42.4, 30, 12.7, and 1. All right, stat, calc, over to number 4, enter. All right, and let's go 3 decimal places. So y equals negative 1.061x plus 92.309. All right, so let me write that down. Y equals negative 1.061x plus 92.309. Okay, what is the average temperature for New Bern, North Carolina? Latitude line 35.1083. So this is latitude, which is the top column. So this is an x value. So in my equation, I would do negative 1.061, parentheses 35.1083, plus 92.309. So I'm doing the work right here. All right, so I need to type that in my calculator. Negative 1.061, parentheses 35.1083, plus 92.309. And you get 55.059. Okay. All right, B says, what is the latitude line for a city that has an average temperature of 33.5? So that is temperature. 33.5 is a temperature. Well, if you look at your table, temperature is Y. So Y is 33.5. So in my equation, I need to put it in the Y spot. 33.5 equals negative 1.061x plus 92.309. And I have to solve that. So I need to subtract 92.309 from both sides. So 33.5 minus 92.309, negative 58.809 equals negative 1.061x. And then divide both sides by negative 1.061. And you get x equals 55.428. So 55.428 is your answer. All right. Last one. On your handout, I should have already filled in these heights: 68, 74, 62.5, 62.5, 69, and 61. And the arm span: 74, 78, 61.5, 66, 68, and 63. All right, A says, using the regression equation, predict the height of a person with 5-foot arm span. So I need to get my regression equation first by using stat. (68, 74, 62.5, 62.5, 69, 61, 74, 78, 61.5, 66, 68, 63. All right, stat calc number 4. So you get y equals 1.158x minus 8.225. Y equals 1.158x minus 8.225. Okay, this one you have a 5-foot arm span. Well, arm span is a Y value. So Y is 5 foot. The problem is it needs to be in inches. So 5 feet, multiply that by 12, and you get 60. And we're going to plug that in for Y. So 60 equals 1.158x minus 8.225. You got to solve that. So you got to add 8.225 and then divide by both sides. So 68.225 divided by 1.158. And you get x equals 58.916. So that is your answer for the first one. All right, this next one, predict the arm span of a person who is 7 feet 4 inches tall. Well, that's a height. And if you look up at our table, height is x. So this is an x value, but it also needs to be completely in inches. So 7 feet, you would need to do 7 times 12, which is 84. and then you need to add the 4 inches onto that. So you get 88. So X is 88. But we need to predict the arm span, so we're going to have to plug it into our equation. So 1.158 times 88 minus 8.225. Type that in your calculator. 1.158 parentheses 88 minus 8.225. So you get 93.679 as your answer.